This movie is about dynamic ranges. We're going to begin by looking at the index function, where we're going to be able to select an entire row or an entire column, and then we're going to define a region that we're going to select an entire column within. And then we're going to combine the index function with the match function to set up a truly dynamic range. We're going to briefly take a look at tables, because tables, one of the properties of the table is to expand when you append data, which is sort of the definition of a dynamic range. And we're going to use the table to build a dynamic data validation rule. And then finally, we're going to use the offset function to build a dynamic print range. So we have a lot to cover. We're going to begin by talking about the index function. The index function has several arguments. The first argument is an array. The second argument is the row number within that array. And the third argument is an optional column number within that array. So we can use the index function to select an entire column by identifying an entire column, in this case it's column J, and defining the row number to be 0. So if we don't select any row within that column, we've selected the entire column. I've done that in this formula, and when I click on the formula and try to get Excel to show me the array, I get an error message because the formulas may not exceed 8,192 characters. Not sure how they came up with that number, but that's the limitation. That doesn't mean that this formula won't calculate, however. But when you create an array in this way using the index function, you have to do something with it. It's in there, it's defined, we just can't display it in the way we've been used to displaying these arrays in the prior movies. But it is in there and it is functioning, because I can add the sum product function and sum all the numbers that are in column J, so that when I go over here and add another number, let's say 10, I get a new result. And in fact, I can add numbers to the bottom of the spreadsheet, and even though Excel won't display the array by pressing F9, it'll sum all of those numbers. I'm going to go to J. I'm not going to go to the bottom of the spreadsheet, but I'm going to go down fairly far to cell J50,000, enter a 1, copy that, go back up, go home, and you can see we have almost 50,000 as the total count. So even though we can't display the array, it still functions, and it will still add numbers up within the entire column J. So to select a row, we do something similar. We define the row, in this case it's row 1. The row selection number is going to be 0, and the column number, the optional argument, is going to be 0. So if we don't select a column within that row, we've selected the entire row. And once again, if we don't do anything with the array, they're not much use, and I cannot display it because it's too large. It's more than 8,162 characters. But just as the selection of the column, I can sum everything that I put into this row. So we can also use the index function to select a range. And I've done that here. I've selected the range that includes Monday, Tuesday, Wednesday, and the 4 numbers below each one of those days. And the row argument is 0. So I'm going to select the entire column within this range. And the column that I'm going to select is going to be driven by the match function, which is going to match Monday within the range for the match function, where Monday, Tuesday, Wednesday sit in those 3 cells. The 0 at the end of the match function will give me an exact match. So once I match that column in that range, Monday, the first column, I'm going to sum everything in that column, all the numbers in that column, which equal 4. Notice how, even though this is a sum function, you don't have to press Control-Shift-Enter. The next thing we're going to do is use the index and match function combination to build a truly dynamic array. And we're going to do that using numbers and text. But before we do that, I want to talk about the fact there's 2 limitations to the largest number that you can put into Excel. There's a precision level of 15 places, and then there's a number of decimal places that total 307. I have no idea what that number would be called. But to define that number, we use scientific notation. And scientific notation will automatically happen if we have a number that's greater than 13 decimal places. So that's scientific notation. In this case, I have 24 decimal places. So it's the number E plus the number of decimal places. So that's the largest number. This is the last letter of the Greek alphabet. And we're going to use these two values to determine an endpoint for numbers and text that are contained within a range. Because with the match function, I can leave that optional argument off, the match type, and it will automatically look for a close match. And in this case, since this number is the largest number that you can put into Excel, in a list of numbers, Excel will try to find this number, and it'll go through the entire list. And it's either going to find this number, not likely, or it's going to find the last number in the range and return the position of that number within the range. So it's returning 10, and we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the last number in the range. Text works the same way, only we're going to try to find a match for the last letter in the Greek alphabet because we have text in our range. Number 8 is the position of the last text item in this range, 1, 2, 3, 4, 5, 6, 7, 8. We can combine this with the index function, and I've defined the range to be larger than just where the numbers are. But once again, we're matching that largest number or something close to it. I've left off some 9s. And we're using the match function that's going to return the relative position of the last value in the range. So if I add another value, whatever it might be, I can add 1. The index match will return that value, that last value in the range, and the match function, as we can see, returns position 11 within that range. And that's how the index match function is returning the value that's in that relative position, position 11, in the range that we've defined. Once I've done that, I can, as we have before, do something with that range that has now been defined. This dynamic range that will grow as I append data or shrink as I remove data. I've chosen to use the sum product function to sum all of the values in that range, and we can see that the sum of all those numbers equals what we see on the status bar. For text, I obviously can't sum it up, but I can find the last value in a range. So tables. One of the properties of tables is that they automatically expand when you append data. So I'm going to convert this region to a table by pressing Control-T. My table does have headers, and when I enter, I get the default formatting for my table, which is something you can change if you want to. You can change the default, you can change the formatting after the fact for that matter. So when I append data, we can see by the formatting that that data gets absorbed and becomes part of the table. We can use this property to set up a dynamic data validation. So the first thing I'm going to do is convert our data, our list of cars, to a table by pressing Control-T, entering. And then I want to change the table name on the Design tab, and I'm going to call it Cars. And I don't really have to change the table name. I'm just going to do it just to make this more clear as to what's going on. Once you input a new name, press Enter, and I'm going to put that table name somewhere on the worksheet. I'm going to choose to put it there. And now I'm going to set up a data validation rule by going to Data, Data Validation, Data Validation. I'm going to set up a list, and the source is going to be a formula that uses the indirect reference, referencing the cell K16 that has the name of the table. I'm going to say OK, so that when I now click to get a list of the valid entries for that cell, I see the list of cars that we have in our table. But the best part is that once you get that set up, once you add another car to the list and go back to that drop down, that validation, that value will automatically appear as a valid entry because you haven't defined a static range that contains values. You've defined a table that will expand when values are added. So the last thing we're going to do is use the offset function to set up a dynamic print range. The offset function begins by defining an area, and then you input the number of rows and then columns that you're going to offset from that beginning point, and then determine a height and a width for the array, for the range that you're defining. That sounds probably a little complicated, but it really isn't. So we can use the offset function to build a dynamic print range in the following way. I'm going to build the formula first on the worksheet. We're going to input the offset function. The reference is the region that is going to be containing our dynamic range. So this is the outside boundary of the range that can expand and contract as long as it's within this range. The offset, we don't want to offset at all. We want to have the range defined exactly where it is. So we're not going to offset any rows or any columns. For the height, we're going to use the count A function in this case because I've got text, and the count A function will return a number that equals the total number of cells that contain text. So to define the height, I'm going to use the count A function and create a range that's in a column that's contained within the reference that we defined in the reference argument. I'm going to close the count A function, comma, and I'm going to define the width in the same way. I'm going to use the count A function, only I'm going to define the width by the row that's contained within the reference. I'm going to close the count A function and then close the offset function. And when I enter, or control enter, I get an error because this is an array formula, but that's okay because I just wanted to build this in the workbook because it's easier to do that than to build it within the print range. So that's the next thing we're going to do, is define a print range. And we just need to establish a print range. Anywhere, really, it doesn't matter. The page layout, print area, set print area. So by doing that, I've defined a print area, which is a range that Excel uses to determine what region of the worksheet to print. Now we want to copy out of the formula bar our formula that we just built. Control C, copy that into the clipboard, click off of that, escape, go to the Formulas tab, left-click the Name Manager, and we're going to choose the print area, select the formula that's currently there, and input our formula, and then make all of the references absolute references. Left-click the check mark to accept those changes, close the dialog box, and when I Control P to look at the print preview, we have the 3 columns that say content. I'm going to escape, and I'm going to add some more content by adding another column, Control P. We see that was added to our dynamic print range. And the same thing will be true for another row that gets added to the print range. And again, this will be contained within the region that we defined, or the reference argument for the offset function, which could be huge. So anytime you add content within that reference range, the print area will expand or contract to accommodate the content that's in that range. So we talked about dynamic ranges. We use the index function to select an entire row and an entire column, and then we combine that with a match function to select a column within a range that we've selected. We then built a dynamic range using the index and match function in a region that contains numbers and another region that contains text. We talked about how tables are dynamic ranges within themselves. We converted some data to a dynamic range or a table, changed the name of the table, and used that name as a reference using an indirect function in the data validation rule to make the data validation dynamic. And then we used the offset function to build a dynamic print range.